Hi, everyone. This week we are going to be talking about function operations, and then we'll later in the week look at some consequences, some applications of that. But for now, we'll just talk about function operations, or another way we could say this is how we combine functions. So this is going to kind of extend this function idea that we've been developing for the last couple of weeks and allow us to do some more stuff with it. So suppose we have two functions that we're going to call f and g. Um, this is, kind of this basic function diagram thing where what a function does is take an x value and apply some process or operations to it and pair it with a y value. If the function's called f, then one way we can refer to the y value is f of x because, well, the way we got to it is that the function f took an x value and then, generated the y that goes with it. So similarly, g takes x to f of g, or sorry, scratch that. G takes x to g of x. There we go. Okay, so what we kind of need to be able to do is think of these functions as objects. So rather than just simply thinking of it as, a formula that I plug into or something like that, think about each function as, something that I could like pick up and hold in my hand or something, right? So each function is sort of its own thing. If we think of them as objects, then we can combine them. So I can sort of make sense of what it means to take these two functions at the same time and put them together in different ways. There are two main sort of types or categories of combinations we need to be able to do. One is arithmetic, where we add, subtract, multiply, or divide. And what we're doing when we take two functions and add them together is just, well, adding them together. So mechanically, what we would do is combine like terms, and I'll do an example in a second. But if we add them together, what we're doing is defining a new function that is the result of adding those together. And what we name that new function is f plus g. So if I said, hey, you got that function f and that function g, I want you to add them together. Well, okay, I can do that. I can, whether I think about it point wise, like, let's see what happens when x is 2, plug it into f, plug it into g, add those together. That's the addition function. But if I think about that as sort of doing that for all values at the same time, which is why we would write it with a variable, then what I'm really doing is defining a new third function out of those two. We call that f plus g because it tells us where it came from. Similarly, I'm just going to kind of write these quickly, but it's the same idea. We just combine them. F, there we go. Just combine them doing whatever the indicated operation is. That one's usually written like that, where we're concatenating, putting the things next to each other to mean multiplication. And division, f of x divided by g of x is f over g, where here, to make things work, we do have to require that g of x isn't 0. If it was 0, we'd be dividing by 0, which is undefined. So we do have to make sure to avoid that. So that's combining two functions using arithmetic. And what that would look like is just something like this. Let's say that f of x is 2x plus 1, and g of x is, I don't know, x minus 2. Then if we want to do this kind of function arithmetic stuff, we'll do it in 4 parts here. say I want to find f plus g. Well, f plus g is just f plus g, right? It's exactly what it says it is, basically. But what I know about f is that I can write it as 2x plus 1, right? I have a defined explicit rule for what f of x is. It's 2x plus 1. So in place of f, I can put 2x plus 1. In place of g, okay, that's not what I wanted. In place of g, I can put x minus 2. To turn this from sort of an abstract idea about names of functions into a more concrete thing where I have a symbolic representation of function, a formula, however you want to say that, for these functions. This plus sign is this plus sign, which is this plus sign, which is what the problem was asking me to find, is the sum of those two things. Then we just add. Here, adding means just combining like terms, 2x plus x, 1 plus negative 2, so minus 1. And then this, 3x minus 1, that's my new combined function that I got from finding f plus g. For the sake of at least doing it, let's look at the other operations. The setup is exactly the same. F is 2x plus 1, g is x minus 2. This would be a good place to pause it for a second and try this on your own. One minus negative 2, so 1 plus 2, so plus 3. Multiplication. F times g. By the way, I'm doing all these as f first and g second. There's nothing special about that. If it was g times f, you would do the same stuff. You would just have the order swapped on g and f. Now, the multiplication here, we do want to be a little bit careful because these are binomials, right? There are two pieces to each of these terms that we're multiplying. So the expansion looks something like that then, FOIL if you want, or some people draw the little box thing to do the expansion. However you do that, you do need to be careful to, sort of capture all of it. So 2x times x, negative 2 times 2x, x times 1, and 1 times negative 2, and then combine like terms. And finally, division, f over g. Looks like that. And there's really nothing we can do to simplify this at this point. Later in the semester, we'll talk about how you do polynomial division and what we could, maybe do here to rewrite this thing. We don't have those tools yet, so that's what that is. Okay, so that's the for arithmetic, add, subtract, multiply, divide combinations of those two functions f and g. There's one additional way that we can combine two functions, and that's called function composition. The idea of function composition is that we do one function and then the other sequentially. meaning one after the other. So back up to my f and g thing. Basically, the way function composition works is that I take these two functions and I start with some x value, and when I plug that x value into f, what I get back is f of x. But if I'm composing with g, then I take that value, which I shouldn't make a box around because I don't mean for it to be a function, but I take that value and use that as input for the next function out. And what I get is g of f of x, or the composition of g with f. Sometimes people read this as f followed by g or g of f. But again, what it's saying is you started here, you did this thing, then you did this thing, but I didn't like take a break in the middle. I just sort of did one after the other. Another example of somewhere that we do this in like real life is laundry, right? Washer and dryer. And the way the process works goes something like that. You take your dirty clothes, you run them through the washer, and then, for a lot of us, well, I guess maybe I draw them this way because that's the way mine actually are in my house, but dirty clothes into the washer, turn it on, let it do its thing, and then, take the wet clothes straight out of here into here, and then turn it on, let it do its thing, and then finally what I get out is, the thing I wanted in the first place, which is the clean clothes that are, now dry also and sort of ready to go. So that's the idea for function composition. This is the, first or the inner function. This is the second or the outer one. The way we write this is something like this. This little circle thing is the composition operator. You read that as of. Again, what it means is that we want to compose. That's another way to write the same thing. This inner function happens first. So that's the washer. And then the outer, F in this case, happens second. That's the dryer in my laundry example. And the reason I like the laundry example is because here, as with function composition in general, the order is important. There's a big difference between taking your dirty clothes and putting them in the washer and then into the dryer and what comes out than if you take your dirty clothes and put them in the dryer and then put them in the washer and then take what comes out, right? One direction is going to do the thing you want it to do. The other, going dryer first and then washer, is probably not what you want to have happen. Okay, so quick example. Let's say that f is, what were they before? 2x plus 1, and g is x minus 2. And I want to find f of g. Okay, and again, if you wish, another way to write that is like this. So the thing that we want to kind of focus on is that the inner function, the one that happens first, is g. So I'm not even paying attention to the f part of things right now. I'll look at that later. I'm going to focus on the inner thing because I have to do it first, right? I have to run things through the washer before I put them in the dryer. So I'm focused on that first. And what I know about g is that it's the same thing as x minus 2. So I'm going to replace g of x with x minus 2. That's its representation. That's the symbolic version of that function. I'm going to replace it with x minus 2. Once I've done that, I'm just going to kind of forget about all this and look at this and think about what it's asking me to do. What I need to do is figure out what f does. So evaluate f or plug in for x minus 2. Okay, here's f. F takes a thing and gives you 2 times that thing plus 2. So f of x minus 2 looks like that. Where the missing thing here is this, because I'm evaluating or plugging in x minus 2. Okay, now all the f's and g's and stuff are gone, which means that I've gone from dealing with this kind of abstract idea of how these functions combine into a concrete formula equation type thing that I can simplify and work with. So I'm just going to simplify it. Sorry, I don't know what happened there. So I'm going to distribute the 2 and then combine like terms. 2x minus 2. This then is the new combined composition function of f with g, or g, f of g, or g followed by f. So this is like the, if you want to go back to the laundry thing, this is like me saying I'm doing laundry, right? Rather than saying I'm going to use the washer and then the dryer. Sorry, I circled the wrong thing. I'm going to use the washer and then the dryer. Now I'm just saying, hey, I'm going to go do laundry. This function sort of guides me through the whole process because I've combined the things. Just for the sake of doing it real quick, let's do that same composition but the other way around. So g of f. So g of f. Again, this would be a good time to pause for a moment and try this on your own. So you want to do the same thing, but switch the order up. F is 2x plus 2. G of 2x plus 2, well, g of anything is going to look like that because that's what g does, x minus 2. So leave a placeholder here, minus 2. So placeholder minus 2. And then the thing I'm plugging in is 2x plus 2. And then just start cleaning up the algebra. 2x plus 2 minus 2, so 2x. So that's the composed function in the other order, g of f. The thing to notice, especially right now, is that these are not the same, which means that the order is important. So it does matter which order we do those in. Okay, we will look at this some more in class and do some more examples and talk more about what it means, and we get some cool things from this, so we'll look more at those. But that should hopefully give us a starting point and kind of an introduction to things. So please let me know if you have any questions. Otherwise, we'll see you in class.